Okay, guys. So in the final video, and I think like just the final video for the chapter and even the course, I'm just going to talk about very quickly about something called the inverse of a matrix. Okay, inverse of a matrix. So the inverse of a matrix essentially says that suppose you have a matrix A. So so if you multiply A into a matrix X and the result is your identity matrix I, this X is said to be the inverse of this matrix A. So what do I mean, right? So suppose you have a matrix which is A, B, C, D. Suppose you have a 2 by 2 matrix. Now, if you multiply this into a matrix, which is, let's say, which looks like this. So X, Y, Z, W. So this is said to be the inverse of A if and only if when you multiply this matrix into this, the result you get is an identity. Remember identity matrix? So what was an identity matrix? It's a matrix which has ones in its diagonals and 0 everywhere else. So then this matrix X is called the inverse of the matrix A. So how do you actually go about finding the inverse of a matrix? So I'll just do the 2 by 2 case, and the 2 by 2 case is because there's this simple formula for it. So suppose your matrix A is equal to A, B, C, D. The inverse of this matrix, which is denoted as A with the power of -1, is just 1 into 1 divided by the determinant of A. So you find the determinant, and then you're going to multiply it to a matrix. So this matrix is going to be based on this, but the terms are going to be rearranged. So how do you rearrange them? So this is the formula, okay? So the D and the A elements, they get switched. So you write D here and A here, and then you put a minus sign in front of B and minus sign in front of C. So if you do this calculation here, you're going to get another 2 by 2 matrix. Okay, you just do matrix multiplication, and this 2 by 2 matrix is going to be called the inverse of A. Okay, so why is this an important thing to know, the inverse of a matrix? And again, I don't want to get into too much detail, but the inverse of a matrix can also be used to solve for systems of equation, because it has this very useful theorem. So there's this useful theorem which is 16.6.2, which says, suppose you have A into X being equal to B. From here, you can actually solve for your matrix X by writing this is equal to B into the inverse of A. So if A into X, these are all matrices. For matrix A into matrix X equals to matrix B, you can actually solve for matrix X by writing, I mixed this up. Sorry, so X will actually be the inverse of A into B. Okay, this order is important. So this is theorem 16. So you can actually write your matrix X equals to the inverse of A into B. So just sort of, I'm taking this down, so you're writing it the inverse. Okay, so how's this handy? Let me show you how you can use this rule to solve for a system of equations. So I'm just going to quickly do example 16.6.5 from page 648. Okay, so over here you have two equations: 2x plus y equals to 3, 2x plus 2y equals to 4. Okay, so you can use the theorem I just showed you to solve for this system. Okay, let me just show you how. Okay, so let's write this in a matrix form. So 2, 1, 2, 2. This is your matrix A into x by y would equal 3 by 4. So remember, you're trying to solve for x by y. So A, this is A, you have some matrix X equals to matrix B. So remember the theorem I just showed you. From here, you can actually write that your matrix X is equal to inverse of A into B. Okay, so what does this mean? So what is inverse of A? So your A is 2, 1, 1, 2. Remember the inverse of A? I just showed you the formula. The inverse of A is this. So I can actually write the inverse of A as 1 by the determinant of A into, you take these elements and remember what do? You switch these elements. So D goes into A's place, A goes into D's place, so which is still 2 by 2. And then you put a minus sign in front of 1 and minus sign in front of 2 into the matrix B, which we know the matrix B is 3 by 4. Okay, but here you can do one more step because you know what the determinant of A is, right? So the determinant of A is 2 into 2, 4, minus 2 ones are 2. So the determinant of A is actually 2, 4 minus 2. So it'll be 2, and then you have this matrix here, 2 minus 1, 2, 2 into 3 by 4. Now this is just a scalar getting multiplied to this matrix. So you can just multiply through. So half into 2 is 1, half into minus 1 is minus half, half into 2 is 1. Sorry, this is minus 2. Half into minus 2 is minus 1. Half into 2 is what? Again, it's just 1. So if you multiply this, and then you have 3 by 4, right? Okay, so now notice that, what does this mean? So remember, so we learned matrix multiplication, right? So this over here, you have a 2 by 2 matrix, right? And over here, you have a matrix which has 2 rows and 1 column. So if you multiply this, you're going to get a matrix which is equal, which will have, so the answer for this is going to be a matrix which is going to have 2 rows and 1 column. So there's going to be some result here. Let's say M and N. So there's going to be 2 rows. So 2 rows and 1 column. So actually so when you multiply these 2 matrices, according to the matrix multiplication rules we learn, it's going to be a 2 into 1 matrix. So you're going to get some results here, and actually these results, M by N, is just going to be equal to your matrix X. What was your matrix X? Remember, your matrix X was X and Y. So once you do this multiplication and you solve for M and N, whatever the answers you get, actually M is going to be equal to X, N is going to equal to Y. And I think in the book they solve this and they say this M and N, you actually solve them. They solve that this is 1 by 1. So if you multiply this, if you just use matrix multiplication rules, you can solve for it and you'll get 1 by 1, and these results are actually equal to, so so your X is equal to 1 and your Y is equal to 1. So this is another method, so we've learned a few methods to how, so this just boils down to, okay, how do you solve systems of equation? So just previously we were doing at the Kramer, we were looking at the Kramer's rule, but now I showed you one more method, which is how do you use the inverse of a matrix in order to solve a system of equations. And so you guys can just practice some problems. Stick to 2 by 2 matrices because otherwise it gets pretty complicated, okay? And that's it, okay? So that's the last video I'm going to be posting for the course. And I just want to, I know it's not been the easiest, course to do with, especially at the end with all that's happening, but I hope you guys are all safe. And, I hope these videos were helpful, and good luck for the final that's coming up, okay? Okay, bye everyone.